So welcome everyone. I know this is a sponsored session, but I promise only open source stuff will be talked about here. My name is Pushkar Joglekar. I'm a principal security engineer at Broadcom. I've focused on VMware Kubernetes service inside of VMware Cloud Foundation. I am also a Kubernetes security maintainer, and that's what we are mainly going to talk about. The first two slides, you will feel like what has this got to do with Kubernetes, but bear with me. So about 2 weeks back, I was in Pittsburgh returning a rental car, and I picked up the rental car location that was available in my email receipt by the car rental company. I went there and it was somewhere in the middle of nowhere, and no airport was close enough, there were no cars. I was sort of surprised what's going on. Then I went all the way back to where I was, looked only at the overhead physical signs that said rental car return, and then I reached the right place. So clearly the official destination for returning the car on the digital world on my email was wrong, but the overhead signs took me in the right place. This was easy because I was living in physical world and trying to depend on a digital information in my email. When this becomes more complicated is when you have text in digital form. Some of it is human generated, some of it is AI generated. There was a research paper published about 3 years ago now by some Stanford graduate students and faculty, where they did a study with a group of people and tried to ask them whether this block of text is AI generated, whether this block of text is human generated, and it was essentially a coin flip regardless of the use case. What that means is some people said human generated text is AI generated, and some people said AI generated text is human generated. And this is the chart in the paper. You can go read more with the link at the bottom. It's basically called human heuristics for AI generated language are flawed. This becomes an even bigger problem when the text records are actually about CVEs, especially Kubernetes CVEs, which is what we are going to talk about. Because if we don't know what to trust in terms of reliable information on Kubernetes CVEs, then we really don't know what to fix, what is the risk of our clusters. So just quick you can raise your hand or shout out the answer. How do you all get information about Kubernetes CVEs today? Security scanner, emails, something else. So probably the answer is mixed and there is no particular clear winner. The other piece to mention here is generally if patch fixes are available and you are upgrading, then majority of the CVEs the fixes for them you consume, but there are some CVEs that are not fixed and will not be fixed in Kubernetes since many years. Fortunately, all of them are medium or low severity, but in the world of AI assisted vulnerability discovery, I'm not sure what severity really means anymore. So first question, how to identify if a CVE is unfixed? Typically you would rely on again your security scanner. If they don't provide a fixed version, then you know that this is unfixed. If you do have a fixed version, then you know it's fixed. But how do they get that fixed version is based on information that's provided by Kubernetes maintainers and also provided by a global organization which maintains CVE records called MITRE, which you might have heard about. So today these three signals exist to get reliable information on CVEs. There is an official Kubernetes CVE feed on official Kubernetes docs. If you haven't looked at it and search official K8s CVE feed, you should see a page there which has details about all the CVEs we know. This is maintained by a community including me and many others. Like I said, there are of CVE records in general for all general CVEs, including Kubernetes CVEs, that are in cve.org/CVE URL, and then you can just input a CVE number there and then find the answer. The source of truth, or the main thing that Kubernetes maintainers rely on in terms of keeping up to date the status of the CVEs and announcing CVEs to the rest of the world is Kubernetes/Kubernetes repo GitHub issue, which is created by SRC, which is nothing but Security Response Committee, a group of about 9 or 10 people across different companies who work together privately to review the disclosures that are sent to them and then work with the other maintainers to fix what they think is worth fixing. You can find more info about them in the link in the slides. So there are some CVEs like this one, CVE 2020-8554, which is CVE that is known as an unfixed CVE. It is documented correctly in the CVE feed, in the CVE records, but in GitHub issues up till a couple of weeks ago, there was no label called won't fix or anything like that. So the issue was basically open, which wasn't a great signal in terms of what we wanted to convey. There are 3 more CVEs. I won't go into details about each of them, but the main idea is this was another one found 5 or 6 years ago, which is about webhook redirects. There is one more called related to how DNS works and how you can work around the caching mechanism there to do time of check and time of use kind of attack. And there is another one called cross namespace forwarding via endpoints. So this is largely not relevant if you are running a newer Kubernetes version, but for anyone who upgraded from an older one or using a older Kubernetes version, which is like in the 120 range, is impacted by this. There are more details on all of these CVEs on the GitHub issues. So if you search this, search for a Kubernetes/Kubernetes issue that has this number in the title, you will be able to find more information. The problem with these 3 compared to the other one is these are all mentioned in CVE feed highlighted as unfixed. So you will literally see it marked in bold compared to all the fixed CVEs. The CVE records actually were broken in terms of they were essentially saying that all of these CVEs are fixed when they are not in fact fixed, and the CVE records had an erroneous fixed version for each of these 3 CVEs. This was something we found as we were working on implementing and making improvements to the official CVE feed. So what happened was there is almost a desire from community different communities who consume Kubernetes CVEs to have all of this CVE feed information in OSV format, which you might be familiar is a standard open source vulnerability format that is used by several different ecosystems. While generating that OSV format, we found that the tool that automatically converts our CVE feed JSON to OSV feed JSON actually gave us wrong results because it was relying on the records, and the records themselves were wrong. And the GitHub issue completely contradicts the CVE records, because GitHub issue is basically saying we are not going to fix this, this is not going to be fixed, and there are several comments about it like are we going to get a fix, and there are discussions saying like this is a design choice, we will not want to change this fundamentally compared to the risk that this poses. So now we have an interesting scenario to test AI and hallucination around AI. AI relies on data on the internet. It doesn't know who realistically is the right judge of whether a CVE is fixed or not fixed. Even for all of us humans, some of us might trust the CVE records, some of us might trust the GitHub issues, but it's not one answer. And now we have a difference between CV records and GitHub issues completely contradicting each other. So I, as a user, about 4 weeks ago asked some of these questions, and I wanted to walk through some of them with you to show, like, when you don't have a single source of truth, does AI help you find that balance of, like, what do we trust? And then if AI is right in this scenario, do we think AI is more trustworthy than the humans who generated the CV records? So I asked, assume you are in 2022 where there are no blogs or no other information discussed about this CVE, and this was just published. You have no idea about the new content that was generated after that. Is it possible for you to tell me if I am vulnerable to this CVE or not? So I'm not going to say which AI it was. I don't want to say like this AI is better, this AI is worse. So you can try this experiment yourself. Just repeat the same question that I did or something similar that you want and see what answers you get. What AI did was, okay, I reviewed this CVE. As of right now, this is considered unfixable by design, which is correct. You are vulnerable if you are using mutating or validating webhooks with profiling true. This is also correct. The smoking gun is that if log level is 10, then the API server will leak redirected response. This is also correct. So it's basically saying if you have log level that is 10 and you are running a Kubernetes cluster with profiling true, you are vulnerable. Now I kind of pushed back on the AI, said, like, when you gave me this answer, you also gave me a list of sources, and those sources were actually published after 2022. So you're saying I am thinking in terms of being in 2022, but you're using the sources that are published after 2022. Then, as expected, AI said, my apologies, I'm stripping all future content as of early 2022, which is when the CVE was disclosed. This is a live SSRF flaw around redirects. Official stance is there is no code fix because it would break third-party admission controllers. Hardening via disabling profile is the only current mitigation. So this is essentially what is in the GitHub issue, and the maintainers have explained that. So this is correct, and then when I got the response back, it did not use the source that were published after 2022. Now I went back and then tried to push again because we know the CVE records are wrong at that time and the GitHub issue has just been created. I said, like, okay, in 2022, are you sure there is no fixed version? Because CVE records is saying that there is a fixed version. What makes you say that there is no fixed version? So AI was like, okay, yes, you're right. The Kubernetes Security Response Committee's official advisory says fixed versions none. This is due to breaking change risk, which is kind of what it explained earlier. If they stop following redirects, the ecosystem would break, etc., etc. And so this is not a patchable bug. Now, again, like, because I know the CV record is wrong, and even if we forget, like, it's not looking at 2022 world. At the time I asked this was still wrong. Whether we fix the CV record or not later, I'll come back to that in the later part of the slide. So then I said, like, okay, tell me how the CV record shows a fixed version in that case. If you're saying in your previous response that there is no fixed version. And then they said, okay, the discrepancy is actually due to industry tracking. While the committee says fixed version is done, NVD database, which is the CV records list 120.11, 121.5, 122.2 as fixed. These versions don't remove the redirect behavior, but they harden the server to prevent the specific log leak exploit chain. So what it is basically saying is the way the disclosure happened, there was a specific code path that was exploited, and there was some hardening done there, and it didn't explain what. So from what it was trying to explain is because that code path was fixed, this fixed version is correct, but the committee is also right that in general this vulnerability is not fixed and is unpatchable. So this is where it gets confusing, like as an end user of Kubernetes, I'm like, there is no clear answer, like what are you trying to tell me? And then I then again started discussing more from a perspective of, if I don't have internet access, if I don't have AI access, and I'm purely relying on my scanner to tell me whether my Kubernetes cluster is vulnerable, in 2022, will it flag this vulnerability for 121.6 version, which is actually ahead of the fixed version described here. So this answer does make sense. It says it will mark it as fixed. Most scanners use the NVD threshold. So today people can tell me that some scanners don't do this, but most scanners will always rely on NVD and CVE records. They will not have the contextual information about GitHub issues and then be able to tell like whether something is fixed or not. Some scanners also have their own set of records that they maintain and then rely on that, which is augmented on top of what NVD provides. So what it's saying is most scanners use NVD threshold. Since 121.6 is greater than 121.5, the scanner will show pass, which means this is fixed, but in reality it's not fixed. So technically the redirect vector still exists. You are just protected from the easiest leak that was exploited. That's what it is trying to tell me. So this is a lot to grapple with, and as maintainers, our responsibility is to make this as easy to understand as possible when it comes to important things like CVEs. So what did we do after that? We started, like with all things, a GitHub issue saying this is wrong, these CVEs have wrong information, we need to fix this. Then Kubernetes Security Response Committee started working with me and some others, said like, okay, we will fix the CVE record. And for context for everyone, this group of members are the members who do have access to publish and update new and existing CVE records. Nobody else in Kubernetes can do that, but they will be able to publish new CVEs and update the records as well. There are several ways to do that. You can go through the CVE records website directly. You can also use GitHub security issues machinery that they have, and then that gets refreshed back up to the CVE records. So we did a couple of things as part of this work. One is went ahead and fixed these 3 records. The other CVE that we talked about earlier, which did have the right CVE record, was not showing it in the same format that is recommended by MITRE. So we also updated that CVE record for 2020-8554, I believe. And then second thing we did is, if you go to any of these GitHub issues for all of these CVEs, you will find that all of them now have a new label called won't fix for all of these CVEs. It's in blue, and it's on purpose on blue because we want to tell that this is not something to cause alarm, and this is not something to be worried about, but this is a conscious decision by maintainers to not fix it, and there are reasons for that which are described more. So this blog was published around I want to say end of May or so, and on June 8th, June 1st actually, June 1st we did the changes. Now the next step for us is, now that the CVE records are fixed, community has had a chance to consume that. We wanted to get some feedback, which we started getting. So one of the good news that came out of this is this the 4th CVE that we talked about. If you go to the GitHub issue for that, there was a comment made by someone who said, well, actually we are fixing this for real this time. And then there is a KEP link to that. So now what we have done from our side is keep this as open in terms of GitHub issue, but when the KEP is published, we will update the CVE record to reflect the fixed version of when the design is actually implemented in the newer Kubernetes version, and at that time only these 3 will remain as known unfixed CVEs in Kubernetes. So if you think this is interesting and maintaining a single source of truth in general that's authoritative is useful in the world of AI and wanting to not trust AI blindly about something, I'll give one more example. As many of you might be aware, AI will lag behind the real time updates on anything it's tracking. So the issue I said, which is going to be fixed, when I asked about it yesterday while I was finishing up on slides, it said like, I am very, very confident this is not going to be fixed because based on my information, this is not fixed. The maintainers have said this is not fixed. But if you go look into that issue, there is a fix in progress, and AI was basically again wrong, saying like, I am very confident this will never be fixed again. So from maintainers perspective, to not be in a coin toss scenario in terms of what do we trust, humans or AI, we want to have this documented very correctly, have authoritative sources like the CVE feed, which is currently in beta stage of a feature, which will soon be GA. There are a couple of things that we are trying to work on. If you want to help on that, that will be awesome. There is also a VEX KEP. For folks who are unfamiliar, KEP is a Kubernetes enhancement proposal, which is essentially a design doc for all the other industry terms. The reason to have VEX along with the CVE feed is there are several scanners that will also scan the Go module dependencies of Kubernetes, and then any CVE you find in that Go module dependency will also come to the maintainers and say like, hey maintainers, are you going to fix this? My scanner told me this is vulnerable. It's a lot of churn. Maintainers have to keep responding. We looked at this. This is not really impacting Kubernetes. We don't run this code. We don't execute this code, or these preconditions do not apply to Kubernetes. So we want to have this all automated in a machine readable way. So for that we are working on a draft for a VEX official feed, just like a CVE official feed that we have. We meet, so this is all done through SIG Security group. We meet every other week on Fridays. A bunch of the tooling work on official CVE feed and VEX is done by a sub project within SIG Security called SIG Security Tooling, and that sub project meets alternate with the main meeting of SIG Security. This is every Friday. You can find the links on what Zoom to go in, adding it to your calendar invite on the Git repo of SIG Security. Lots of work that I described is been going on for many months, and there is many more months of work needed to do many things that we want to do that I described. So last slide, which is just a little bit from my employer. We do contribute a lot on in open source. These are some of our Kubernetes projects that we have donated from Broadcom. We also support and have active maintainers in Cluster API, HCD, Containerd, and Kubernetes CSI. We do have, including myself, contributions and membership in SIGs and tags, and I'm here for community days, for example, and we do sponsor KubeCon as well as KCDs. There is an ongoing commitment from my team as well as my peer teams to contribute to Kubernetes. If you are interested, our team is hiring. Happy to chat with anyone. The only 2 criteria we are looking for is you have a desire to contribute to Kubernetes and you want to make things better with a focus on upstream. With that, thank you so much. If you have any feedback for me or the organizers, please scan this QR code. They will receive the feedback and they'll be able to share that with me as well. I'll really appreciate it for my own improvement.